Who are there? You and Pranati?
I don't know, sir. People didn't even attend class. That was.
So today, first, what should I start from the solid waste or you want air pollution? Will you start from air pollution or solid waste? Air pollution contain more
Anything
part.
is fine.
Air pollution contain more part. So like if we explain air pollution, it will be better, I think. Then I will go for the solid waste. Already we have studied anyway. So that once I will try to finish the air pollution, then I will go for the solid waste management part. Is it okay, right?
Okay, sir.
Pranati is there. Pranati. Yeah.
Yes, sir.
Yeah. So today it's a sixth session, like last session actually. So So Professor Narendra here. These are the classes has been recorded for the AICT Prerana initiatives for the GATE aspirant. And this is the sixth session on my onwards. I'm from CMR Institute of Technology. So today we will be discussing. We are discussing about the environmental engineering. Environmental engineering 1 and 2 we have discussed about the water and wastewater treatment, municipal water treatment and supply, and wastewater engineering and treatment. So this is like we are moving for the next portion for this GATE syllabus, which is related to air pollution and control management as well as solid waste management, municipal solid waste management. In the all classes, we have told about the GATE 2021 pattern, how will be the exam pattern will be there, and IIT Bombay is conducting this exam. There will be 100 marks question, right? 3 hours duration computer based exam. So this is the portion for the environmental engineering. So environmental engineering, water and wastewater, water quality and treatment part we have covered it. So we have done everything here. Left and discharge of this portion, use of treated CV, different applications. And my previous lectures we have completed this. Today I will be discussing about the air pollution as well as the municipal solid waste management. Let's start for today. Yeah. We are coming for the air pollution part. The sources, impact, control, and measurement. We see if we look at this label part, they're concerning about the types of pollution, their sources and impact, air pollution control, air quality standards, and air quality index and limits. So 1 to 2 marks for this, and then 1 to 2 marks for the municipal solid waste. So altogether, statics has been given here. This section wise, and explain and other sites also. Yeah. So first you have to understand what is pollution actually, and what are the pollutants. We'll be specifically we are talking about the air pollution, as actually there are the 4 types of pollutions which are typically noticed, which is the water pollution, air pollution, soil and land pollution, and noise pollution. So anything which is not desirable for the environment, anything which create a problem for the environment, anything which cannot be digested, which cannot be biodegraded, it creates a harmful impact for the ecosystem as well as the living as well as non-biotic system. So which is called as pollutant or pollution. Yeah, environmental pollution. And maybe in terms of water pollutants, if the water pollutants are there causes the water pollution, maybe it's in terms of air pollutants, right? So today we are talking about the air pollution. Basic terms, the introduction of contaminants into the natural environment that causes adverse changes The pollution means substances introduced to the environment which adversely affect the usefulness of our resources. Pollutants are component of pollution. Foreign substances, energies, or naturally occurring contaminants. Factor affecting the severity of a pollution is the chemical nature, concentration, and persistence. These are the three things which has to be noticed in any kind of pollutants, right? So first, the pollution you have to understand understand what type of pollution it is. Once you identify, you have to go for okay, what are the pollutants are responsible? Your source of pollutants are responsible for creating this air pollution. Suppose I'm talking about the air pollution, various industries, various the automobile vehicle combustion, right? And even the domestic areas also, there's indoor pollution and outdoor pollution. Rapid industrialization, there is thermal power plant, production unit, automobile industries, right? And even the there is a cluster of industries, textile, cotton, synthetic textile, paper and pulp industries. Everywhere, if you see, even the steel manufacturing industries, everywhere, if you see there is a sort of air pollution they are generating it through the stick, right? And they're burning something on a very high temperature. They need energy. Maybe the most of the cases they are fossil fuel based energy emission is going on. So if you are burning a fossil fuel, of course, the various um, types of pollutants will be releasing into the atmosphere. So the three things is important. One is the chemical nature. You have to understand the pollutant chemical nature. Second one is the chemical nature means how it is reacting with the original composition of the gases, right? So we have if you see the atmosphere, I will talk about the atmosphere, right? Various layers and all that, and we have a typical composition of the gases. So once this pollutant is released into the atmosphere from the various types of sources. So what is how it is chemically react with the existing gases, how it is react with with chemically with the existing environment, and what is the composition finally once the chemical reaction completed. What is the further we can see the chemical, yeah, acids, yeah, whatever the component, yeah, toxic compounds will be generated, and how it is harmful for the environment. Second is the concentration, on what concentration, what percentage it is diluting, what percentage it is dispersing, what percentage it is, we can say the mixing with the environmental gases. That is important. So concentration you have to identify. So for that, there is a measurement technique. Once you identify the pollutant, you have to measure the pollutant. There's the various air pollution measurement devices, air sampler, analyzer, volume samplers, and then we have a NOx samplers for capturing the particulate matters, also concentration. We have a, particulate matter PM10 and PM2.5, right? So various pollutant measurement devices we have it. So we have to check the concentration in the air first. Then we can understand, we can tell the severity of the condition for the particular type of pollutant. And we, of course, these pollutants are having bad impact on human being everywhere, right? While you're talking about the impact of these air pollutants in atmosphere, right? And second, third one is the persistence in nature, the pollutant, which how long it will sustain into the atmosphere, how long it will survive, right? If it is not decomposed, if it's not biodegraded in the nature, for how long it will survive, how long it will be there in the nature, maybe in a dilution form, maybe in a persist, maybe in a dispersion form, or maybe it will mix with the water, right? Depend. So these three things has to be measured before going for any kind of pollution. So today I'm talking about the air pollution part. So pollution terms began to draw major public attention in the United States between the mid 1950s and early 1970s, when the Congress passed the Noise Pollution Control Act, and then Clean Air Act, as well as the Clean Water Act. The National Environmental Protection Agency and National Environmental Policy Act has also come. There's a US EPA, Environmental Protection Agency, which has formed these laws. Right. So what is air pollution exactly? You see that the air pollution is the introduction of chemical, particulate matter, or biological materials that cause harm or discomfort to human or other living organisms, or causes damage to the natural environment or built environment into the atmosphere. A substance in the air that can cause harm to human or environment is known as an air pollutant. These are the well-known air pollutants. We have a classification of the pollutants. There's a primary air pollutant as well as the secondary air pollutant. So commonly we have seen the release of chemicals and particulates into the atmosphere. The gases pollutants include carbon monoxide, sulfur dioxide, the various forms of sulfur, and then NOx, nitrogen dioxide, NOx, NO2 or NO3, then chlorofluorocarbons. They are in the form of various gases: NOx, SOx, carbon monoxide, volatile organic compounds, particulate matters, dust, smoke, fumes, mist, and there are particulate matter PM 2.5, PM 10, which are responsible for the air pollution, right? Smoke is also one type of pollution only, and then various radioactive gases which will also release into the atmosphere causes the air pollution. So if you see the first composition of gases in a clean air in our atmosphere, this is the typical composition of gases. So without any pollution, these this is our atmosphere. In stratosphere, we called as we have a typical composition of these gases, right? So nitrogen is roughly 78.1%, oxygen is 20.9%, argon is 0.9%, carbon dioxide is roughly 0.035%, and other gases are 0.065%. And some of the other inert gases are also there, like neon, helium, krypton, hydrogen, xenon, ozone, radon, right? So this is the pie chart. If you see that we have a 78% or 79% nitrogen only. The remaining 21%, 20.9 to 21% is the oxygen. This is the percentage weight by volume. So CO2, carbon dioxide is around 360 ppm, yeah, 0.03% for the total. Neon is 18 ppm, helium is a 5 ppm, and methane is a 1.7 ppm roughly. So these are the typical fresh composition of gases in our atmosphere. Now, once the pollutant release, these types of pollutant release, and it will mix with the atmosphere, it will react with these gases, and it will form through the various chemical reactions, and various biochemical reactions will be taking place, and they will form the pollutants, right? Secondary pollutants, all that. So human activities can release substances into the air, some of which can cause problem to human, plants, and animals. So there is an impact on human, impact on plants as well as the animals. There's a natural composition of gases we have explained now, right? We'll go for the control and measurement technique, then we'll talk in details. This is the structure of atmosphere. This is our atmosphere. Above the earth is the structure of atmosphere. So atmosphere is the space above the ground, and this is the life blanket of earth. These are the various spheres that we have divided our sphere. Above the ground, we have divided our sphere in various forms. So there's a troposphere on the bottom, starting from the ground level to up. Okay, there's a troposphere layer 0 to 10. There is a tropopause also. This is a part of troposphere only. Then second is the stratosphere. After stratosphere, we have a mesosphere, and then we have ionosphere, and there's a thermosphere, and there's an exosphere, right? So various conditions regarding the temperature, regarding the altitude, like height, right? Height from the ground, we have divided our atmosphere, and there is a gases composition. Like the various the temperature will be different in all layers, in all spheres, like different temperature in various spheres, as well as the pressure will be different, as well as the wind direction and wind speed also will differ. And respectively, while the altitude is increasing, okay, the temperature is also decreasing. So like this, there is a lot of climatic factors, meteorological factors that will play an important role. And so we have divided our whole atmosphere in three or the six sphere, actually: troposphere, stratosphere, mesosphere, ionosphere, and thermosphere, and exosphere. This is the distance given, and then various gases composition also we have explained here. This is the altitude, and this is with respect to temperature, and then temperature, what is the temperature and various spheres. Okay, yeah. So atmosphere is divided in layers according to the major changes in temperature. Gravity pushes the layer of air down on the Earth's surface. This push is called as air pressure. 99% of the total mass of the atmosphere is below 32 kilometer only. So this is all. This is we have noted down. 99% of the total mass of the atmosphere is below 32 kilometer. Our atmosphere layers are characterized by variations in the temperature resulting primarily from the absorption of solar radiation, visible lights at the surface, near ultraviolet radiations in the middle atmosphere, and the far ultraviolet radiation into the upper atmosphere. So UV radiation play a very important role because it's a harmful waves which are creating a lot of problems. So that's why the ozone layer protect from the UV radiations. So these are roughly things that you already know about it. There is a troposphere. So start from the troposphere. This one is the atmospheric layer closest to the planet and contains the largest percentage, around 80% of the mass of the total atmosphere. Temperature and water vapors contains in the troposphere decreases rapidly with altitude. The upper boundary of the layer known as the tropopause ranges in height from 5 miles or 8 kilometers near the poles up to the 11 miles or 18 kilometers above the equator. Now we'll come for the pollution. These are the common air pollutants which are responsible. I have here also have briefly told about the pollutants. Okay, now I will go for the classification sources as well as the representing symbols. Right, there's the carbon monoxide, carbon dioxide also. Most of the 80% it will come from the automobile emissions as well as the fossil fuel based industries also where the incineration and burning is happening. Various oxides of sulfur, SO2 and SOx, SO3 and SO2, coal, fuel burning, etc. There are the hydrocarbons also, hydrocarbons, unburned fuel, C2H2, see the various benzene formation and all that. The various hydrocarbons will be releasing from again from the industries and unburned fossil fuel emissions, automobile vehicles. 100% combustion will not happen inside the internal combustion engine. So unburned fuel releases this hydrocarbons, which will create a lot of problems for the. That's the main reason for the air pollution actually. Various oxides of nitrogen, NO and NOx and NO2 combustion process it will release, and the particulate matters like volatile organic compounds PM2 and PM2.5 and PM10, and suspended particulate matter also, respiratory suspended particulate matter. We will go for the again classification for the particulate matters and particles. Okay, maybe it will be in suspension and dispersion form. It will be in suspension most of the cases. These are the sources of air pollution. There are the two types of sources of air pollution. One is the natural sources. Another one is the anthropogenic regions. Anthropogenic regions means the man-made region that man has created this pollution. So if you see the natural sources of pollution, we have like forest fire, volcano eruptions, sea salt sprays, biological decays, pollen, grains, marshes, photochemical oxidation of terpenes causes the natural sources of pollution. Thermal thunderstorms sometimes, right? So in volcano eruptions, these are the main reasons for the air pollution, natural reasons. These are associated with the man-made reason actually because of the forest fire and these all the reasons are coming again because of the excess mining as well as the cutting the forest, deforestation happening with the rapid stage, right? And there's the water pollution everywhere. There's the air pollution, soil is contaminated because of the man-made reasons. Anthropogenic reasons like thermal power plant, vehicular emissions, automobile vehicle emissions, and various industries are responsible for creating this air pollution. And even the indoor air pollution is also considered nowadays. This is also because of the man-made reasons only. Excess population rise and high rapid urbanization is also the main reason for the air pollution. And meaningless consumption of the resources, natural resources, maybe water, air, soil, and whatever the other minerals that we are using it without thinking about it, and we're creating a lot of solid waste problem also. And we are polluting soil, we are polluting water, we are polluting air. So most of the reasons are anthropogenic reasons. Excess deforestation is also the main reason we are cutting the forest for our daily needs. Okay. So based the sources has been classified here. These are the sources of emission of air pollutant. What is the percentage that is causing the air pollution? So industries contribution for this air pollution is 52%. Various types of industries: automobile production, manufacturing, textile, steel manufacturing, thermal power plants, right? Cotton industries, pharmaceuticals, your paper and pulp industries, daily food processing industries, right? Food consumable, FCMG industries. So all kind of industries. There's a cluster of industries. Everywhere we are using resources, and everywhere you are using energy resources and water resources, and everywhere. And then you are there are the big furnaces, boilers, steamers, right? All big machineries are running because of the electricity and all that. They are using electricity and all that. So everywhere in the form of directly and indirect form, they are releasing various air pollutants daily basis. So 52% largest contribution in the air pollution comes from the industry. Then from transportation, all kind of transportation, rail transport, air transport, road transport, altogether contributing in this air pollution 27%, because traffic, air transport also, all the aircraft fuel combustion. We are using aircraft is using high octane number gasoline, again creating a pollution. All the aircraft carrier also, the satellite carriers also causing the air pollution. So altogether, it's 27% coming from the transport sector. Then the consumer and commercial product 8%, commercial and residential heating 1%. Agriculture sector is also causing air pollution. They are going to for the open burning. They are burning their residues at the farm, then again creating air pollution. Altogether 10%, and remaining is 2%. So sources has been classified herein based on the origin of the source, based on the spatial distribution, right? So number first is the based on the origin of the source. We have a natural sources like dust, storm, forest fires, volcano eruptions, anthropogenic sources like man-made, exclusive industries, thermal power plant, and automobile. We have classified the origin of the source. Second is the based on the spatial distribution. We have a point source based on the spatial distribution. Point source like industries at place, right? There's a movable source as well as the fixed source also based on the position. Like the aerial sources like industries, industrial areas and cluster of the industries are causing the pollution. And then based on the position of source also, there's a stationary source of pollution and there's a movable source of pollution. Stationary sources are like various industries which has been fixed in a particular location and creating a pollution, generating a pollution day by day. Then there's a movable source like the truck in on highways, movable source like trains, right? Automobile vehicles, aircraft, right? These are the movable sources of pollution, which is spreading a pollution into the atmosphere. Okay, so like this, we have a various classifications. Now, based on the origin, we have a primary air pollutant as well as a secondary air pollutant. This is very important. Primary air pollutant as well as a secondary air pollutant. So, primary olive pollutants which will release directly from the source, okay, like the carbon monoxide, carbon dioxide, various SOx, NOx, nitrogen dioxide, and all that, and then various hydrocarbons, unburnt combustion is happening in fossil fuel based emissions, fossil fuel based combustion engine, internal combustion engines, and then these the complex chain of hydrocarbons, carbon and as well as the hydrogen. These molecules will be coming from the source, and then various volatile organic compounds. It's types of hydrocarbons only, and suspended particulate matter also a part of primary air pollutants. Right? There's a secondary air pollutants. Once the primary pollutants will release into the atmosphere, it will react with the atmospheric gases, and then it will form the secondary pollutant. These are the secondary air pollutants, like the ozone, H2SO4, peroxycyl nitrate, PN, right? H2SO4, ozone, PEN, PBN, PPN, smoke, right? Due to the photochemical reactions, the smoke is generated. These are the secondary pollutants. And based on the nature also, we have pollutants like two types of pollutant. We have organic pollutant as well as inorganic pollutant. So organic pollutants like various hydrocarbons, right? Inorganic pollutant like SOx, NOx, carbon monoxide, and various gases. Based on the state of matter also, pollution is sources, yeah, the air pollutant has been divided. So there's a particulates which will be in the liquid forms. Some of the particulate matters will be in a gaseous form. Some of the particulate matters will be in solid forms. So in that way also, liquid, solid, and gaseous forms also we have divided based on the state of matter. So the particulate which are in liquid forms called as mist, gaseous forms like carbon monoxide, SOx, and NOx, and solid forms like hydrogen, hydrogen gas, and solid pollutant. These are the various criteria of air pollutants. The name of the gases which has been released from the particular source has been given, and what are the characteristics for the particular type of pollutant has been explained here. So here, if you see this nitrogen dioxide, N2 in air is oxidized easily, NOx, sum of NO, NO2 and other oxides of nitrogen. The color is brown for it. Gas irritates the respiratory system, originates from the combustion. Sources burning fuel including petrol, diesel and coal. Ground level, ozone, primary constituent of smoke. Reaction of VOC, which is released from the combustion of the IC engines, plus NOx in the presence of heat and sunlight. It will react it will form the VOCs. Vehicular emissions in industries are the major source for it. Carbon monoxide. The characteristics for this carbon monoxide is very dangerous. It will like uh, block your respiratory tract system, and then it reduces the blood ability to carry the oxygen also. It is again produced from the incomplete burning of carbon fossil fuel based emissions and natural and synthetic products such as cigarettes and all that. One cigarette is having more than 4,000 chemicals which are very harmful. There's a passive smoker as well as the active smoker. So it creates a lot of indoor air pollution. I will talk later about the impact of the pollutions. Carbon dioxide, principal greenhouse gases are the major constituent, major characteristic for it, emitted as a result of human activities such as the burning of coal, oil, and natural gases. Sulfur dioxide, because of to the acid rain along with the NOx, sulfur dioxide is the main reason for the acid rain. Acid rain create a lot of water pollution, right? Formed when fuel, coal, oil containing sulfur is burned in the metal smelting, right? Then there's a chlorofluorocarbons, CFCs, which will be the ozone layer is depleting because of the CFCs only, greenhouse gases, yeah, chlorofluorocarbons released from the air conditioning systems and refrigeration systems. There's a lead causing learning disabilities in children, toxic to liver, kidney failure, as well as blood forming organs. Lead is also very harmful. Present in petrol, diesel, and lead batteries, pens, hair dyes, product, and etc. There's a particulate matter, PM10, PM2.5, which is also releasing continuously. Okay. Before coming for this, I will just go for the impact of air pollution. Then I will talk about all the numerical portions, what are the concentration and all that. Just briefly, I will tell you these things. Then I will explain the impact of air pollution on planet and all that thing. Then I will come for the numerical portion for it. These are the concentration formulas and all that. And these are the hydrocarbon dispersion and dilution techniques, the adiabatic lapse rate as well as the environmental lapse rate. I will talk about it. Stability of the environment, I will talk about it. And then there's the various dispersing mechanism, how the pollutant is dispersed, how the pollutant matters, pollutants will, particulate matters will disperse into the atmosphere, how to decide the stability of environment, right? And dispersion and dilution, how does it occur, right? The various gases law I will talk. So I will come later for it. I will just go for the environmental significance and pollution. We were talking about the air pollution here. Yeah, these are the air pollutants, health effect of pollution because of the air. Actually, if we see here, air pollution which is released from various industries, automobile vehicles, even the commercial and the construction activities, building infrastructure development, various particulate matter, carbon monoxide, ozone, SOx and NOx, lead. It damages your nervous system. These volatile organic compounds, which will also causes the cancer risk, right? Skin irritations, Various allergic symptoms will come because of the VOCs. SOX and NOx causes various respiratory illness, your cardiovascular system also, the cardiovascular diseases also, because it will block your blood circulation systems and all that. There is various gastrointestinal diseases also which will come through the air pollution. I will come here about the air pollution part. Not water pollution, air pollution. Yeah. So these we have discussed already. Now, there are the sources of we have classified air pollution in two parts: indoor air pollution as well as the outdoor air pollution. So, the effect of air pollution we will study. First, we will see the sources of indoor air pollution in your indoor air pollution part. And then effect of pollution. Yeah. So we'll be talking about the sources. I mean the impact of air pollution. I will talk later. First, I will go for the where it is. Yeah, here. So these are the sources of indoor air pollution. There's a two types of pollution as we have classified: indoor and outdoor. Because of the poor building ventilation, spray insecticide that you are using it for killing the insecticide in your house, cockroaches and all that, anti-reptiles that you are using at your home. It is having various chemicals, various chemical gases, right? We are various VOCs. New building materials that you are using in your constructing your house, like polymers, PVC, pens, vanishes, asbestos, and rugs, also causing an indoor air pollution. So what is happening, like the paint, whatever you are selecting for it, whatever the construction material you are using for the for constructing your house, it should be sustainable material and green graded as a green building material, so it can impact. It can reduce the impact of air pollution, indoor air pollution, because the color coding is very important. Various colors will absorb the UV radiation more, and the temperature also of indoor temperature will rise. So it is very important to while you're selecting your building material, right? Microbial contaminants, various viruses, bacteria, fungi, bathrooms, which will release from your bathrooms in wet areas. Sick building syndromes, bioallergens from the AC and formaldehyde from the insulation. Odors from domestic activities like NST from your perspiration, mercaptan from the tobacco smokes and all that. Firewood cooking also, because when a firewood cooking, what is happening, incomplete combustion is happening, incomplete combustion of wood emitting source, causing soot, which is having carbon monoxide and carbon dioxide, which will release into the atmosphere. In your old age, in villages and all that, firewood cooking is common, so it causes a lot of air pollution. And these are your effect of air pollution. So that I will just open this. So one house itself, you see that how much emissions of we are releasing it, and for the indoor air pollution, the chemical release from modern buildings and furnaces buildings, right, causing air pollution, indoor air pollution. Then combustion of gases from fireplaces and wood burning stoves from your kitchen, right? Animal hair and renders, right? Chemical fumes from pens and solvents releasing. Gases including radon seeping through the foundation, the percolation infiltration of gases is happening, right? CPs formation. Then various gases released from like carbon monoxide, fumes from attached garage. Cigarette smokes contain more than 4,000 chemicals. The chemicals from your cleaning products, mold and bacteria, outdoor air pollutants, right? These are the responsible things. So effect of air pollutions are there on human health, animals, as well as plants, as well as the material, as well as the environment. These are the effect, severe effect of air pollution on human health, animal, plants, material as well as environment. So I'll going for one by one about the human health first. Effect on human health. The main problems are related to the respiratory tract, asthma, hay fever, and other allergic diseases. Irritation of the eyes, nose, throat. In severe cases, there may be a headache, nausea, and loss of coordination. Prolonged exposure can cause damage to the nervous system, digestive problems, and in some cases causes lung cancer. It lower our resistance to cold and pneumonia. Carbon monoxide has affinity toward HP, which causes disturbances in your transportation of oxygen, impairing our concentration, slow our reflexes, and make us confused and sleepy. So carbon monoxide is very harmful. It causes cardiovascular diseases also. Sulfur dioxide in the air leads to disease of the lungs and other lung disorders such as wheezing and shortening of breath. Chronic respiratory diseases, lung cancer, heart diseases, even damage to the brain, nervous system, liver, and kidney. Effect of arsenic, asbestos, mercury, and benzene. These are the toxic substances, which poisonous substances, which causes a lot of problem for the human health. Okay. Then there are the effect on plants also. Pollutants enter through stomata. These air pollutant enters through the stomata and leaf. It is there. Destroy the chlorophyll and affect the photosynthesis process. Photosynthesis process is the only process through this you are getting a fresh oxygen into the atmosphere through our producers like plants. In the making process of this photosynthesis process, the food making process of plants, what they are using it, the huge amount of carbon dioxide, sunlight, various nutrients they are absorbing from the soil, and the water that is needed. So they are absorbing these nutrients and releasing as a plant's healthy growth cannot happen. There's a cuticle wax layer on leaves is lost. There's a various botanical diseases, necrosis, damage to leaf structure, chlorosis, loss or reduction of chlorophyll, abscissions, dropping of leaves, epinesty, downward curling of leaf, and death finally. These are the various diseases which is happening because of the air pollution. The color degradation is happening. The leaf is dying, right? You see that for various plants, right? So these are necrosis and chlorosis, abscissions. These are the epinesty. These are the various diseases. Various impact of air pollution. These are the injuries in because of the pen. Pen is damaging the milkweed leaves. Light injuries, moderate injuries, and heavy injuries. Okay. The effect of animals and materials are also severe. Corrosion of metal surfaces, feeding the color of our buildings, right? Our historical monuments, like marbles, degradation is happening because of the sulfur dioxide and H2S. Because what is the repeated abrasion and corrosive action? What is happening? The color is converting into the pale yellow color, right? The slow degradation is happening for our historical monuments. That is happening. Disfiguration of the statues made up of limestone or marble. Air pollutants mixed with the rainwater and increases acidity also. That is the main reason for the acid rain of water body, and it causes the water pollution and kills faces, all the water animals. Ozone causes cracking of the rubbers, ozone layer depletion. UV radiation effects are quite common, right? And then effect of environment like visibility. Global warming is also one of the reasons because of the greenhouse gases. The global temperatures warming is happening, right? Temperatures rising rapidly. Our ice glaciers are melting, right? Emission of greenhouse gases causing tends to the global warming. Chlorofluorocarbon causes ozone layer depletion. Pollutants in the presence of the sunlight produces photochemical smoke. This photochemical smoke is very harmful. Huh? In the presence of sunlight produces photochemical smoke, and that is visibility will be less. And then while you are breathing this toxic air, again, a lot of problems will be happening. Yeah. The national ambient air quality standard I will talk later while I'm going for the solution. First, you have to understand the severity of the problems. So you have severity of the pollution. So this I already talk about it. Lungs damage, gastrointestinal systems, systematic pesticide herbicides may penetrate in the skin and damage blood cells. Carbon monoxide from the incomplete combustion may deplete or react with the oxygen in blood cells and hemoglobin circulation and trigger cardiovascular diseases, result into death. Nitrogen dioxide irritates the lungs, causing bronchitis and pneumonia, may cause trigger asthma, right? These I have already spoke about it. This is the ozone reduces the lung function, causes coughing, sneezing, chest pain, and pulmonary congestion. Objectionable odor and taste. Corrosive or chemical effect of fluoride as well as hydrogen disulfide or NOx, etc. on objects, exterior of the building and monuments, right, are deteriorating of these monuments. Human skin damages, spoilage of fabric and leather dresses, various insecticides and various cosmetic products causing the skin cancer problems, right? So there are the eight type of pollutants which are responsible for skin cancer. Reduction in visibility of the air traffic, soot and smoke impair sights also causing problem. There's a phytotoxicology effect on fluorine on the flowers as well as the fruits and plants. Once the fluorine content exceeds 0.3 microgram per cubic meter, it creates a phytotoxicology effect which will transmit from the various trophic level from primary consumer to secondary and tertiary consumer and then decomposes. So it will these pollutants will keep transmitting from one body to another body and it creates a problem. And from the it creates a lot of problem for the flowers and fruits. And then excess hydrogen disulfide, sulfur dioxide, hydrogen disulfide clog the leaf stomata, as I told you about the plant effect of pollution on plants, reducing carbon dioxide intake and adversely affecting the photosynthesis process. As I told you, this photosynthesis is the only source of oxygen. If the photosynthesis process is disturbed, we will not get the sufficient amount of oxygen from the plant. These are the producers. Cattle grazing on vegetation contaminated from fluorine may develop fluorosis. And then arsenic poisoning, arsenic, lead, as I told you about the lead contaminated particles. Now, these are the things like where it is it's talking about. Yeah. So these are the main pollutants: arsenic poisoning leading to the vomiting in irregular pulse, may be caused by ingesting of leaves sprayed with the insecticides, causing a lot of problems. And bioallergens also is a problem on the human being. 80% population is suffering for the allergic symptoms. Allergy may be in the form of this skin allergy, breathing allergy, and all that. On the environment at large scale, air pollution may cause the acid rain, ozone layer depletion, global warming. These are the well-known worst environmental impact: acid rain and ozone layer depletion and global warming, causing because of the air pollution only. Pollutant, I have already discussed about the primary pollutant as well as secondary pollutants. Now I will come about the air pollution and control measure. So measurement is important. Okay, once I go for the measurement part, then I will come for this control measurement part of pollution. Okay. Yeah. So first is, as I told you, the concentration play a very important role. You while you're measuring the pollution, you have to understand about the concentration. Concentration generally, like what is, like if you see generally in mg per liter, we talk in water, no, milligram per liter, right, in water in form. In terms of gases, there's a this is different, right? In terms of gases pollutant, you are measuring it. So concentration of pollutant, the unit will be also different here. The concentration of air pollutants are monitored in atmosphere and expressed in terms of microgram per cubic meter. Yeah, ppm or ppv sometimes. The microgram per cubic meter is most common unit while you're going for particulate matter concentration, SOx concentration, NOx concentration, everything you're going to measure in microgram per cubic meter. So generally 1 ppm is equal to 1 mg per liter hota hai, right? Only for the water. But 1 ppm is not equal to 1 mg per liter in terms of air or gases. So we have a gases law, that is PV is equal to RT. T is the temperature in Kelvin, and T is the atmospheric temperature. R is the universal gas constant, which will be 82.05. There are the four laws for gases I will discuss later. 82.05 10 to the minus 6 um, atmosphere into cubic meter by mole into Kelvin, right? So this is the whole unit for it, for the gas constant. At a standard temperature and pressure, just a minute. Yeah, now it is fine. This is the unit for the gas constant. And then at standard temperature and pressure, STP, I will call STP from now onwards. This is standard temperature and pressure. That is standard atmospheric and room temperature and atmospheric pressure. P we are taking in degree Celsius. P is 1 atmosphere temperature we are taking it, and V is the volume. You can get the gases volume by using this formula. V will be equal to divide by 1. 1 P will be in the right hand side, and R is given 82.05 into 10 to the minus 6. Multiply with T, multiply with the what we call as 273. It's a room temperature, right? And then divide by 1, you will get it as 22.4 into 10 to the minus 3 meter cube. This is a 22.4 into 10 to the minus 3 meter cube. You are getting it finally. Now you have to find out the concentration of carbon dioxide, carbon monoxide, sulfur dioxide, NOx. You can get it through this. Suppose concentration of carbon monoxide is given 9 ppm, 9 mg per liter. So 9 into 10 to the power 3 divided by 10 to the power minus 3, you will convert into the microgram per cubic meter. Okay. Liter to cubic meter conversion, you can do it. Based on this, you have to divide by 10 to the minus 3, that you have done it. And mg to gram, microgram, you have to convert it. Then you have to multiply with 10 to the 3, that you have done it. Then finally, you got the unit here, microgram per cubic meter. So 9 into 10 to the power 6 microgram per cubic meter you will be getting here. But this is not right in case of gases, right? So generally we do this calculation, right? Mg per liter we convert into that case, but it is not valid for the gases case. For the gases case, we have to go for the different theory, because liquid cases is fine. Generally, if you are getting a 9 ppm, you will be directly converting in microgram per cubic meter, but it is not right. So here, for the gases concentration, for measuring the gases concentration, the m gram of any gas at STP, standard temperature and pressure, occupy as 22.4 in 10 to the power minus 3 cubic meter of space, as we have told here, that we have calculated, right? So m gram of any gas as STP occupy 22.4 in 10 to the power minus 3 cubic meter of space. Now 1 cubic meter of any gas at STP weight, you have to calculate m gram that you have taken it, divide by 22.4 in 10 to the power minus 3 gram. So 1 ppm is equal to 1 part of any gas divided by 10 to the power 6 of part, 10 to the 6 part of air is equal to 1 cubic meter of any gas divided by 10 to the power 6 cubic meter of air. So 1 ppm will be equal to here m divided by 22.4. I'm doing a basic calculation here. 1 ppm will be equal to m divided by 22.4 into 10 to the minus 3 into 10 to the 6 gram per cubic meter. So you convert finally m by 22.4 into 10 to the 3 gram per cubic meter. You can, if you want to convert in microgram per cubic meter, you can convert in that way. So m into 10 to the power 6 divided by 22.4 into 10 to the power 3. So if you want to convert a carbon monoxide, the concentration of carbon monoxide, if you want to determine, you have to use this formula finally. So at 1 ppm at STP, standard temperature and pressure, at 1 ppm will be equal to, this value will be given m gram of a particular gas, divided by, you have to divide by 22.4 into 10 to the 3 microgram per cubic meter. So this is the right estimation for it. Suppose if you want to find out the concentration of carbon monoxide, you have to go in that formula. So m is given as 9 ppm, 9 mg per liter. Respective conversion you have to do that form. And another thing, if you go reverse, 1 microgram per cubic meter at STP, then you have to, this equation you will take it, if you want 1 gram 1 microgram per cubic meter, then it will be reverse here, 22.4 divided by m into 10 to the power 3 ppm. So that also you can do it. So any of the conversion you can do. This is the right conversion for converting up for getting the concentration of particular gas. Okay. Generally, microgram per cubic meter, you have to take it everything. So 1 microgram per cubic meter will be equal to 22.4 divided by m concentration is given there, multiply with 10 to the 3 in ppm mg per liter. You have to do the respective conversion. So 1 ppm at a respective temperature and pressure will be equal to giving m gram, whatever the concentration is given, ppm, whatever it is given, m divided by constant, that is 22.4, constant, multiply with 10 to the power 3, this is constant 22.4, and to multiply with 10 to the power 3 microgram per cubic meter. M is the molecular weight of the gas. So carbon monoxide molecular weight, you can take it. 16 plus carbon molecular weight. So 1 microgram per cubic meter at standard temperature and pressure will be the constant divided by m into 10 to the power 3 ppm. So these are the two formula, one formula and second formula. Same as it is if it is a 1 part per billion at standard temperature and pressure, that will be the same formula applicable for it. The constant will be 22.4. So this is the question now. The 9 ppm of carbon monoxide at a standard temperature or pressure will be 9 ppm, it is given, into multiply with m molecular weight divided by 22.4 into 10 to the power 3 microgram per cubic meter. So 9 into what is the molecular weight of carbon, molecular weight of oxygen, addition of the both two. So molecular weight 9 into carbon 12 plus 16 divide by 22.4 into 10 to the power 3. This is the right estimation. So you will be getting at 11,250 microgram per cubic meter of concentration in the atmosphere. So like this, you can measure the gases concentration into the atmosphere. So it will be 11.25 mg per cubic meter. 11.25 mg per cubic meter you will be getting here. Correct? Now, the concentration of chloro. Second question, concentration of chloroform you want. The same way you can do it like this also. 1 microgram per cubic meter. It is given in 0.4 microgram per cubic meter. Now the second equation you have to use. This is the given here. So 1 microgram per cubic meter is equal to, this is your formula, constant divided by m in ppb. So the constant will be equal to 0.08205 into 293. 293 is standard temperature divided by 1. You will get it as 24.04. The 0.082282 this one 8205 is the molecular weight of this CHCl3. So 0.04 microgram per cubic meter will be equal to here. See, this is the Avogadro constant R. We have measured, no? This one is the Avogadro constant. I'll show you here. Here we have done, no? Here, this one. V you have calculated, and this one was the complete 24.4 into 10 to the minus 3 cubic meter. Same. This is the 24.04. 24 point, yeah, because here 293 into 23 divided by 1, so 24.04 you got it. Now you can apply this formula here also, then you will get it finally 0.08 ppb. So like this, you have to measure the concentration of various gases in an atmosphere. Now next question is, convert 120 microgram per cubic meter of SO2 into ppm and ppb at temperature is given at 10 degrees Celsius and pressure is 1 atmosphere. सल्फर का molecular weight 32 दे रखा है, oxygen का 16 दे रखा है given question. So it's standard also, it is not given. You keep always remember the table, no, gases table. So this is the formula, 1 microgram per cubic meter is equal to constant divided by m in ppb. So you can write it 23.22 through the gas constant you have measured, this one, divide by molecular weight, how much it is, 32 SO2, right? So 32 plus 16 into O2. So you will be getting as 0.362b28 SSB. Is that PPT visible?
No, sir.
What is it? Oh, meeting disconnected. Just a second. Please let me know once the people like if PPT is not visible, you have to immediately tell because I'm busy in
Okay.
explaining the. From how long? Like how much before it disappeared?
5 minutes, sir.
5 minutes only. Okay. This net can this is disappeared. Just a second. Always internet. 1 minute, just it's internet problem is there. Yeah. The student, that internet is not working, the college internet. So the 1 hour lecture tomorrow will continue. Is it fine? 1 hour we have taken today. The next 1 hour will continue tomorrow. Because the internet is not
Yes, sir.
working
No
in the
problem.
college. Yeah. So tomorrow we have classes. I think evening will take this. Okay. And anyway, your IITs will start late, no? So tomorrow all you can come and join, and then we can continue, right?
Sure.
Okay. Tomorrow we will continue. Huh? Okay.
Yes, sir.
Okay. Yeah. Thank you for the class. Tomorrow we'll meet. Okay. Same time.
Thank you, sir.